Hello, welcome to the third and last case study of the semester. Today we have a case of an enterprise that has a distribution network, but they have problems because they have detected very high costs because of the way they have their operation in the present. They have three categories of products: confectionery, chocolate, and high-end chocolate. They have three production plants, and they have a single product dedicated to a single product, and they have 8 distribution centers dedicated to one product or two products. They have customers, 103. We have their zip code and their coordinates. But we also have these facilities, the plants and the distribution centers with their zip code, and we have to calculate their longitude and their latitude so we can get a distance between them, so we can optimize this system. We have the demand in kilograms of 6 periods for each product and for every customer. And then we go to the table that we will have an important constraint, that is that the plants and the handling capacity of the same plants and the distribution centers, not all of them can have the three products in the production and in the distribution network, in the handling. So we have to define the best performance measure considering the available information. And the cost defined as relevant for the company to keep track of are the administrative costs of handling the products for leasing and loading the trucks, the transportation cost of the products, and the leasing cost of the distribution center. Not the plant, that is not important because that is where it is produced. The company needs to decide which distribution centers want to keep part of this network and which one take part of. And we also know that it can be directly moved from the plants to the customer, or the distribution, or the plant to the distribution center, and distribution center to the customer, and the customers to other customers. So we want to see which is the more efficient way.
Our objective is to minimize the company cost. We have our sets of production plans, DCs, products, customers, and periods. Also, we have our parameters for the distances, plans to DC, distances DC to customer, and plan to customer. We have our cost of load transporting. Also, we have administrative cost of handling the product for deliveries from plant to DC, from plant to customers, and from DC to customers. Also, we have our capacity in kilograms of product DC, we have our demand for K of consumer C in period P, and we have two compatibility metrics, one for production plants with products and another with DCs. And so here we have our variables that are the units of kilograms sent of product from production plant to DC, from plant to customer, from DC to customer, all in the periods P. We have our binary that is 1 if DC is least, and in our model we want to minimize the transportation cost times the distances that are multiplied each one by its corresponding variable, the same with the handling cost that each one is multiplied by its corresponding variable. And here we have the fixed cost added multiplied by the binary variable. Here we have our demand constraint that says all the things that we are sending to our customers have to be greater or equal to the demand. Here we have our capacity constraint that says that all the things that we're sending to the DCs have to be less than the capacity of the DCs. And here we have our balance constraint that says that all the things that we're sending to our DCs, they cannot send more than that. And here we have this constraint that says that if our DC is 0, we cancel all the units that we're sending from the DCs, and these ones are constraints for the compatibility matrices that are adjusted to the capacity and to the demand.
We use the Haber-Sein formula for calculating all the distances involved on our model. Here we consider the latitude and the length of 2 points and the average radius of the Earth. We researched on a document of the Instituto Mexicano de Transporte for a direct cost for the transportation that is represented on pesos per kilometer times kilogram, and here is the cost that we are considering on our model. Also, we assign a fixed cost for in case that a distribution center is chosen, and for this we based on a reference of a 1,500 meters squared warehouse with a price of 60,000 pesos per month. And with this, we assign a fixed cost of 480,000 pesos. With all this information, we have here our program where we're calling external Excel files with all the distances calculated. And here we have the results, where we got a minimum cost of 250 million pesos. None of the distribution centers are chosen, and that means that all the products are transported from the plants directly to the customers. All this information, the model and the tables are attached with our delivery.